For camera, we will be using Cinemachine. Cinemachine is a powerful collection of tools and systems for managing and operating your camera in the game. So for our Cinemachine to function, first we need to install the package of the Cinemachine. Go into Package Manager and install Cinemachine package. It is present in the Unity registry. Create virtual camera. Remember that all our essential components, like camera, should be on the essential scene. Good. Now we need to create a pivot for the camera to follow. So create an empty object called camera pivot. Then make the camera follow the pivot. And fixate the look at the pivot. Now our camera follow and look at the pivot, but at a wrong angle. You can change the offset at which camera is present and follow the pivot by simply dragging the virtual camera around. Or in the inspector by changing the offset parameter of the body. Good. Now we want to add a way to control the camera around. To do this, we will move the camera pivot. We are moving pivot around because our camera is following the pivot. So create another new component called camera controller. Inside, when we press direction buttons, we want to move our camera around. So let's form a move vector. So read the horizontal input as a move vector by x-axis and vertical move by z-axis. Then apply formed vector to the position of our pivot. So add move vector multiplied by time delta time and multiplied by speed at which you want your camera to move around. Let's make speed into serialized field so we can change it in the editor. So now if I press directional buttons like WASD, my camera will move. But you will see this weird damping effect of camera correcting to the new position. We need to remove the damping. Good, now everything seems fine. But if I hold both up and right button, my move speed of camera is higher than it should be. It's because we're combining two vectors at the same time without normalizing them. So go into camera controller and normalize the move vector. So now no matter what direction I press, my camera will move at the consistent rate. Good. Let's extract camera movement into separate method, so our code will be a little more cleaner. Now let's introduce rotation of the camera. Create a new method called rotate camera. Inside, read the input of Q and E button. and we want to rotate camera around the pivot point. Make the variable for rotation speed. Make the vector 3 rotation and when we press Q, set the rotation Y to be rotation speed multiplied by time delta time. And to rotate into opposite direction, in the E button press, set the rotation speed multiplied by time delta time, but it is a negative value, because we are rotating into opposite direction. Add the calculated rotation to the Euler angle of our pivot point. And nullify the rotation. Set the rotation speed to be 50, and let's try to rotate the camera. It looks good, but we have two problems. First, the damping. Remove damping from rotation. And if we rotate the object, when I try to move camera, it still moves on X and Z direction based on the world position, not relative to the rotation of our camera. To fix this, when we calculate move vector, use forward direction of our pivot to calculate forward movement relative to the rotation of our pivot object. And use transform right to calculate left to right movement of our pivot relative to rotation of pivot object. I made a mistake, we should use vectors like this, and this should work perfectly fine. Good. Now let's make zooming feature. In the camera controller, create a new method called zoom. To make zoom, we will change camera FOV, so make a reference field for the virtual camera. To do this, we need to import Cinemachine library. So now we want to calculate and set the target FOV for the camera, based on the player input. Make min and max FOV variable. To set the minimum and maximum zoom level. And on the start, read the field of view of the camera to set the starting level of zoom. Now inside zoom method, add to the target FOV the zoom view delta value, meaning if you scroll up or down, your zoom change. Let's add multiplicator called sensitivity. And then make sure you clamp your target FOV between min and max FOV, making zoom limited. Set the fields in the Unity. And let's launch it. Good. This episode is brought to you by generous support of people on Patreon and viewers like you. Please click on like button if you like the tutorial and you have any questions, leave a comment. If you want to support further, you can find my Patreon in the description and be featured like those cool people you can see on the screen right now. Back to the usual program. Okay, we made camera controls, but we are using an legacy input system, which does work, but a new input system is way more modular and customizable and easier to maintain in a larger product. Install a new input system package from Package Manager. When your Unity asks for restart, accept it. After the restart, let's start changing the created system to use new input system. First, we need to replace event system to use new input system. Select event system and press this button. Then we need to create input mapping. To do this, create input action object in your project. Double-click on this new input action to open it. First action we will add is for the player to be able to move camera. Add player action map. Rename default action into camera move. Set camera move to be 2D vector and add input. Because we will be inputting a direction between left to right and forward and backward, it is a 2D vector of input type. Good. Now we need to bind buttons input to the action. So bind VISD to the direction input. Press Save Asset to save changes. Close the manager. Good. Now let's use those inputs we created to move the camera around. Select Camera Pivot.
Add player input component.
So we will be able to read the allocated player input. And add action map we have created. Now we need to utilize this input. Open camera controller. We will be using input library, so import input library. Then we need to create on input camera move path context. And inside, read the value from the context and save it into move vector. Good. But before we do that, let's clean out legacy input out of our character controller implementation. Now in the Unity editor, set the behavior to be Unity events. Open player category. And now we can add callbacks into the camera move event. That means every time when player commits the input correlated to the camera move, our VASD input, it will call function referenced in this event, which allows us to process the input. It should work now. Something is off. I think it's because we're overriding the vector too many times and it's losing the value at some point. So let's pack the input into separate value. And try to use it instead of using the same variable for both reading the input and applying the calculated movement vector. Yes, that was the issue. Good, it works well. So we have a move camera input, but no input for rotating camera. Open the input action. Inside, let's map out the input for rotating camera. Action type will be value, because we will be reading a value, and control type axis, because it's an axis between rotating to the left or rotating to the right. Map out the input to be Q and E presses. So inside camera controller, create new callback for input of camera rotation. Inside we will read the value into the float variable. Then in rotate camera we need to calculate the rotation around y-axis based on the rotation angle input. Set the event in the editor. Call the rotation camera on update. And let's test this. In case you have weird inverted rotation, simply invert rotation angle input by adding minus to it. Good. One more thing, zoom. It is similar how rotation is set up. So open input action, add zoom camera action, Set it to be value. Add axis binding. In the camera controller, add a new function for zoom input. Create variable called zoom input. Read the value. Call zoom in update, and in zoom method apply the zoom input. Let's test this. Set the sensitivity much lower. Good. Everything seems working fine. This will be it for camera setup for now. We will come back and expand upon this later on. This is it for this episode. Special thank you to ThisOldHashDo and Stormbreaker 9000. See you in the next episode.